Under the floor of the Mediterranean Sea, buried beneath sediment that has been accumulating for more than 5 million years, there is a layer of salt. Not a thin dusting, not the residue left behind on the edge of a glass. A layer of salt nearly 2 kilometers thick in places, pressed down by the weight of everything that came after it, hardened over millions of years into something almost geological in its permanence. A layer of salt so vast that if you could somehow gather it all and stack it, it would bury the entire island of Ireland under a column of white mineral reaching into the stratosphere. More than 1 million cubic kilometers of it. 50 times the amount of salt currently dissolved in the water above it. That salt is a record, a confession, written in mineral form of something almost unimaginable. The Mediterranean Sea at some point in the deep past was not a sea at all. It was a desert. A salt flat stretching from Gibraltar to the coast of Lebanon. A dead basin, 3 to 5 kilometers below the level of the world's oceans, baking in summer heat, cracking in winter cold, crossed by no ship, touched by no tide. This is not mythology. This is not the memory of a flood, preserved in story form across generations until it became something other than history. This is science. The kind of science that lives in rock cores drilled from the ocean floor in the thin layer of mineral deposited in a year without rain. In the chemistry of salt crystals that have not been disturbed since before the first members of our genus walked upright across an African plain. The desiccation of the Mediterranean Sea between 5.96 and 5.33 million years ago was one of the most dramatic events on Earth in the last 50 million years. Geologists call it the Messinian Salinity Crisis. The crisis began when the Strait of Gibraltar closed, when the slow collision of the African and Eurasian tectonic plates finally squeezed shut the last gateway, connecting the inland sea to the open ocean. The basin, already drying faster than it filled, simply evaporated. And what remained was the deposit we find now, buried beneath the blue water that replaced it. And then the sea came back. Around 5.33 million years ago, the Atlantic found its way through again. The barrier broke, or eroded, or was overtopped, and the water that poured through that gap at speeds approaching 30 meters per second filled the empty basin in what may have been as little as 2 years. Sea level in the basin rose by as much as 10 meters every single day at the flood's peak. The largest flood in the recorded history of the Earth erased 5 million years of desert in a decade. But here is the question we're going to sit with tonight. What if the barrier had held? What if the rock was just a little thicker, the plate boundary just a little tighter, the sea level of the Atlantic just a little lower on the day the water first began to seep through? What if the Strait of Gibraltar never opened? What if the Mediterranean stayed dry? We are going to walk through every step of that world tonight, every chapter of the history that never happened. We are going to begin 5.5 million years ago, on the day the last gateway closes and the sea starts to vanish, and we're going to move forward through geological time, through millions of years of drying and deepening and cooling and warming, through the evolution of the creatures that would come to live in and around the greatest desert the world has ever seen, through the rise of something that might be intelligence along the canyon rims, and through the world as it would stand today, in the silence of a planet that never found a name for its own seas. Dim the lights if you haven't already. Let your breathing slow. Listen for the sound of wind moving across a salt flat that stretches further than the eye can follow. This is the story of a sea that never came back. Before we step sideways into the history that didn't happen, we need to understand clearly the history that did. Because the real event, the actual Messinian Salinity Crisis, is so extraordinary that it barely needs embellishment. It is one of the most dramatic things that has ever happened to this planet's surface, and its details carry the weight of the alternative we are about to imagine. It begins with geography. The Mediterranean Sea exists because of a specific arrangement of land and water that has only been true for the last few tens of millions of years. Before that, where the Mediterranean is now was part of the Tethys Sea, a much larger body of water that wrapped around the equatorial regions of the ancient world. As the continents drifted and collided, the Tethys shrank. Africa moved north, Europe moved south, great inland sea became smaller and more enclosed, until by around 7 million years ago, it was connected to the open ocean only through two narrow corridors in what is now southern Spain and northern Morocco. Those corridors were the Betic Corridor, running through the region where the Sierra Nevada mountains now stand, and the Rifan Corridor, threading through what is now the Atlas Range of Morocco. They were already narrow, the mountains were already rising on either side, and the climate of the late Miocene was already dry, already pulling more water out of the basin through evaporation than the rivers and the corridors together could replace. Between 5.97 and 5.96 million years ago, the last of those corridors closed. The exact mechanism is still debated among geologists. Some emphasize the tectonic uplift, the mountains simply rising until they sealed the gap. Others point to a global fall in sea level, linked to the growth of ice sheets in the south, that dropped the ocean surface below the threshold of the sill. Most likely it was both, operating together in the way that great geological events usually work, not through a single cause but through the convergence of several pressures all arriving at the same moment. The closure happened at the same time across the entire Mediterranean basin. Paleomagnetic dating of Messinian deposits has confirmed this. The salinity crisis started simultaneously, dated at 5.96 plus or minus 0.02 million years ago. The sea began to change everywhere at once, as if a valve had been turned. For the first 500,000 years or so the change was gradual by the standards of what would follow. The sea became saltier. The evaporation exceeded the inflow through whatever small and intermittent connection to the Atlantic still persisted. Gypsum began to precipitate from the increasingly saline water, settling to the bottom in thick white layers. The marine fauna died back. Species that had evolved over millions of years in the open, well-connected Mediterranean could not tolerate the rising salt. They vanished one by one, as the water they depended on became something they could no longer live in. Then around 5.6 million years ago, the last connection to the Atlantic closed completely. The basin was alone. What happened next was fast, by geological standards. The Mediterranean Sea, which in our timeline covers roughly 2.5 million square kilometers and holds about 3.7 million cubic kilometers of water, began to evaporate at a rate of approximately half a meter per year. That sounds slow, but half a meter per year is not slow when you are trying to fill a basin of that size. The water level dropped, and dropped, and dropped. The eastern Mediterranean basin lost up to 83% of its water volume. The deep abyssal floors of the Ionian and Herodotus basins, sitting kilometers below the surrounding land, remain covered by a residual brine, but the shallower regions, the continental shelves, the approaches to the ancient coasts, the areas where the sea had been hundreds of meters deep rather than thousands, simply dried. The salt flats that formed across these regions were among the most extraordinary environments ever to exist on the surface of the earth. In many places around the Mediterranean, fossilized mud cracks have been found where ancient sediment dried and split in the open air and sun. These cracks are exactly the kind of thing you find today at the bottom of a dried-up lake bed, shrinking and contracting as the moisture leaves. They were preserved, those ancient cracks, when the sea eventually came back and buried them under fresh sediment. They sit there still, down in the rock, witnesses to the time when the sun touched the floor of what we now call the Mediterranean. And the rivers. This is the part of the story that brings the reality of the event closest to human experience, because beneath one of the most densely populated cities on earth there is proof. Beneath modern Cairo, buried under millions of years of accumulated sediment, there is a canyon. Not a small canyon, a canyon up to 13 kilometers wide, carved into hard Eocene limestone by the ancestral Nile River during the time of the Messinian desiccation. The base of that canyon lies somewhere between 1,500 and 1,800 meters below the modern ground surface. If you could somehow drain away the Nile Delta and the millions of years of accumulated sediment and stand on the floor of that canyon, you would be looking up at walls rivaling the Grand Canyon of the Colorado River in Arizona. The river carved that gorge because the Mediterranean dried. When the sea level dropped, the base level of every river flowing into the basin dropped with it. The rivers, following the logic of gravity, cut downward to match the new base level. The Nile cut deepest of all, because the eastern Mediterranean had dried most completely. The gorge beneath Cairo is the most intimate evidence we have of what actually happened. It is a scar left not by any external catastrophe, but by simple physics, by the fact that water flows downhill, and when the hill gets steeper it flows faster. The Rhône of southern France did the same thing, the Ebro of Spain, the Po of northern Italy. Every river flowing into the Mediterranean basin cut downward during the Messinian, carving canyons that in many cases have since been buried under the sediment of the returning sea, or filled by the deltas of the rivers themselves. These buried gorges have been found by geologists drilling for oil, by seismic surveys of the continental shelves, by cores pulled from beneath the seafloor. They are everywhere, along the ancient Mediterranean coastline. They are the fingerprints of a vanished desert. The climate of the empty basin during the desiccation was unlike anything that exists on Earth today, because nothing on Earth today is quite comparable in scale. The deepest parts of the dry basin sat 3 to 5 kilometers below normal sea level. When air descends from a high elevation to a low one, it compresses and warms, at a rate of roughly 10 degrees Celsius per kilometre. Air descending from the rim of the Messinian basin to its floor would have gained 30 to 50 degrees of temperature simply through compression. In summer, when the surrounding landscape was already warm, the floor of the deep basin would have been among the hottest places on the surface of the planet, dry, airless in any meaningful sense, white with salt in every direction, broken by the dark lines of the river gorges, cutting their way toward the residual brine lakes at the lowest points. This was the Mediterranean for 640,000 years in our actual history. And then the wall broke. Around 5.33 million years ago, the Atlantic Ocean found its way back through the Strait of Gibraltar. Whether this was a catastrophic sudden breach or a more gradual process has been debated for decades, and the scientific community remains somewhat divided on the details, but the evidence accumulated in recent years points strongly towards something fast, something dramatic, a waterfall or a series of waterfalls that would have dwarfed any feature in the modern world, pouring Atlantic seawater over the rim of the empty basin and into the salt desert below. The flood that followed discharged somewhere between 68 and 100 million cubic meters of water every second. For comparison, the combined discharge of all the rivers on Earth today is roughly 1 million cubic meters per second. The Zanclean megaflood, as it has come to be called, moved water at a rate 60 to 100 times greater than every river on the planet combined for a period of months to years. Sea level in the empty basin rose at up to 10 meters per day during the peak of the flood. The water moving through the newly formed strait reached speeds of 30 to 50 meters per second at the Gibraltar sill, fast enough that it dragged the air behind it and created tropical storm-force winds racing across the surface of the rising inland sea. The weight of the rising water pressed down on the Earth's crust, flexing it, triggering earthquakes across the entire Mediterranean region. For the animals that had colonized the dry basin during the desiccation, which had walked across the salt flats from Africa to Europe, which had adapted to the canyon rims and the hypersaline lake shores, the flood was the end of the world they knew. A wall of water rising 10 meters every day, moving faster than any animal could run, driven by a force that had no name and gave no warning. The Zanclean megaflood is considered the largest flood in the recorded geological history of the Earth. It refilled the Mediterranean basin, by most estimates, within a decade. All of this really happened. Now, in the timeline we are going to live inside for the rest of this night, none of it did. The wall held, the Atlantic stayed out, the desert remained, and we are going to see what 5 million more years of absence makes of the world. The first thing to understand about a permanently dry Mediterranean is what it is, physically, because the Mediterranean basin is not a flat-bottom bowl. It is a complex, varied, deeply three-dimensional landscape, and understanding its shape matters enormously to the story of what would happen to it. The basin is divided roughly into a western half and an eastern half, separated by a relatively shallow ridge running from Sicily to the coast of Tunisia. In our timeline, this is the Sicily Channel, a stretch of water that can be quite shallow in places and has historically been important for navigation. In the dry alternative, it becomes a low ridge of rock dividing two separate lowland regions, each with its own character, its own climate, its own eventual ecology. The western basin between Gibraltar and Sicily is somewhat shallower. Its deepest points descend to around 3 kilometres below sea level. The eastern basin, from Sicily to the Levant, is deeper, reaching 4 to 5 kilometres in places, particularly in the abyssal plains of the Ionian and Herodotus sub-basins. These two great hollows, in the world where the flood never comes, become the defining geographical features of an entire continental region, stand on the cliff above what would have been the Côte d'Azur of southern France, in the world where the sea stayed dry. Below you the land falls away not to blue water lapping at a beach, but to open air. The canyon walls descend steeply for the first kilometre, then more gradually through a series of terraces cut by the rivers that have been pouring over the rim for thousands of years, and then they disappear into a haze of heat and distance at the bottom, where the salt flats begin and extend to every horizon. The smell rising from the canyon on a summer afternoon is mineral and dry, with the faint chemical edge of the evaporites baking in the heat far below. The birds riding the thermals above the rim are not the seabirds you would expect on a coast. They are raptors, taking advantage of the powerful updrafts generated by the heating of the basin floor. The sky is clearer than any sky above a sea would be, because there is no evaporation rising from the salt flats, no moisture condensing into cloud. The sun on the rim is intense and direct, unmoderated by the sea wind that in our world softens the coast of southern France into something gentle and vine-friendly. The landscape is harder here, drier. The trees that survive near the rim are not olive and cypress, but whatever tough, deep-rooted species can draw enough moisture from the rock to outlast the summer without rain. This is the rim of the Mediterranean sink. This is the edge of the greatest desert on earth, and in the world we are about to explore, it has been this way for 5 million years, and it will be this way for 5 million more. Inside the sink itself, the story is more extreme in every direction. The immediate years after the flood fails to arrive are not, from a distance, dramatically different from the years just before it. The Messinian salinity crisis had already done its work. The sea was already gone. The salt flats already existed. The hypersaline remnant lakes already sat in the deepest depressions of the eastern basin, concentrated and still and barely alive. The canyon systems were already carving their way downward from the continental rims. The animals that had crossed the exposed corridors between Africa and Europe were already establishing themselves in their new territories. What changes, in the world where the flood never comes, is what happens next. The change is not sudden, it is gradual, measured in tens of thousands of years rather than days, but it is irreversible, and its consequences compound over time in ways that eventually transform every continent on Earth. The Lagomare phase, as geologists call the final stage of the actual Messinian event, was a period when fresh water from the north, from the ancient Paratethys Sea and the rivers flowing down from the European highlands, progressively diluted the remaining brine of the basin into something more like a large, shallow, brackish lake. This phase lasted perhaps a few 100,000 years in our timeline, ending when the Atlantic flood swept it away. In our alternative, the Lagomare has nowhere to go. The Atlantic water never comes. The freshwater inflow from the rivers continues, and for a time, perhaps 100,000 years or more, the remnant lakes of the eastern basin grow slightly fresher, slightly larger. But the Mediterranean basin is a place where evaporation always wins. The dry climate of the region, the same climate that caused the original desiccation, persists. The sun takes more water from the surface of the Lago Mar lakes every year than the rivers bring in. The brief freshening reverses. The lakes shrink again. The salinity rises. And within another 100,000 years, the deep eastern basin has returned to something very close to what it was at the height of the desiccation, a landscape of salt's flat and brine pool, extreme and largely sterile at its lowest levels, but with a complex ecology developing along its edges. The western basin, shallower and receiving more river inflow from the Rhone and the Ebro and the smaller rivers of the Iberian and Italian peninsulas, follows a somewhat different trajectory. It dries more slowly and less completely than the east. There may be extended periods when significant portions of the western sink hold standing water, fed by the European rivers, but over the long term the physics are identical. Evaporation exceeds inflow. The water retreats. The salt accumulates. By 1 million years after our divergence point, by around 4.3 million years ago, the Mediterranean sink has achieved a kind of equilibrium. It is no longer actively becoming more extreme. It has settled into the geography and climate that will define it for millions of years to come, and that geography is extraordinary. The salt deposits of the floor of the eastern sink, built up over hundreds of thousands of years of evaporation and precipitation, are approaching 2 kilometers in thickness. Below them, the earlier Messinian evaporites that were deposited during the original desiccation add another 1 to 2 kilometers. The total mineral deposit in the deepest parts of the eastern basin is approaching 4 kilometers of concentrated salt, gypsum, potassium compounds, and other evaporitic minerals. It is, by any measure, the largest single deposit of soluble minerals that has ever existed on the surface of the earth. In our timeline, this deposit was buried and compressed, and eventually hidden beneath the sediments of the returning sea. In our alternative, it continues to grow, undisturbed, building toward an eventual thickness that would stagger any geologist who stumbled upon it. The temperature of the sink floor in summer is, as we noted, extreme. Using the standard atmospheric lapse rate, a basin 4 kilometers deep produces adiabatic heating of roughly 40 degrees Celsius above the temperature at the rim. In a region where the rim temperature in summer already reaches 35 to 40 degrees in a dry year, the floor temperature approaches 70 to 80 degrees Celsius in direct sunlight. Nothing survives that. The floor of the deep eastern basin in July and August is a dead zone, hotter than the surface of Venus is sometimes imagined, hotter than anything in the modern biological world. But the summer does not last forever. In winter the basin floor cools. The adiabatic heating still applies, but the rim temperatures fall, and the floor temperatures fall with them. In the deep basin, winter temperatures at the floor remain above freezing, moderated by the thermal mass of the salt and the warm air descending from above. The floor of the sink is never cold. It swings from lethal in summer to merely brutal in winter, and in the transitional seasons of spring and autumn, it passes through temperatures that life can, with sufficient adaptation, tolerate. This is when the sink comes alive. In spring and autumn, when the floor temperature is somewhere between 30 and 50 degrees Celsius and the sun is lower in the sky, the river deltas that have built up at the base of the Great Canyon systems become active. Fresh water flows in from the Nile Gorge in the east, from the Proto-Rhone Canyon in the west, from dozens of smaller rivers cutting through the rim. Where fresh water meets the residual brine at the edges of the hypersaline lakes, there are transition zones, gradients of salinity from nearly fresh to nearly saturated, and in these gradients, life finds its footholds. Bacteria and archaea dominate the most extreme zones, as they always do. These are not the dramatic, visible organisms of the surface world. They are single-celled, ancient, adapted over billions of years to precisely the conditions that kill everything else. They form pink and orange mats across the surfaces of the hypersaline pools, visible from the rim as a faint flush of colour in the white expanse, the only sign that anything is living down there at all. Around the edges of the bacterial mats, more complex organisms begin to establish themselves. Salt-tolerant insects, descendants of the species that colonized the basin rim during the original desiccation, have been evolving for 1 million years in this environment. By now they are specialists. As different from their ancestors as a deep-sea fish is from its coastal relatives, pale, dehydration resistant, capable of surviving in brines that would kill any insect from the world above, and feeding on these insects, something vertebrate, something small, something that in 1 million years of continuous selection pressure has become one of the most stress-tolerant creatures alive on the surface of the earth. It looks superficially like a small lizard. Its skin is pale, almost white, the melanin having been selected away over generations by the brutal ultraviolet radiation of the basin floor, against which it has instead developed a chemical sunscreen in its outer cell layers. Its eyes are large and adapted for both the bright glare of the salt flats and the deep shadow of the canyon walls. It moves in the transitional seasons and shelters deep in the canyon crevices during the lethal summer months, entering a torpor-like state that reduces its metabolic needs to a fraction of their active level. This creature has no name in our alternative timeline, because nothing with the capacity to name things has yet evolved, but it is real in every meaningful sense. It is the product of 1 million years of evolution, under conditions more extreme than anything in the modern biological world, and it is thriving, in the way that things thrive in deserts, quietly and without spectacle, in the spaces between the catastrophic. The canyon systems that border the sink are, by now, among the most dramatic landscapes on the planet. The Great Gorge of the Nile, which we know from drilling data beneath Cairo, to have reached somewhere between 1,500 and 1,800 meters in depth during the actual Messinian, has continued to deepen in our alternative world, without the returning sea to halt the erosion, without the sediment of the returning delta to fill the gorge. The Aonil has kept cutting. By 4 million years ago, the canyon beneath what will one day be Cairo is approaching 2 kilometers in depth and remains active, still carving. The Rhône Gorge in southern France is, in our alternative, the most dramatic feature of the European landscape. It makes the real Grand Canyon of Arizona seem like a pleasant ravine. Hundreds of meters wide at its lower reaches, with walls of white limestone and grey marl streaked by the mineral-stained runoff of 1,000 springs, it descends from the gentle hills of what would have been Provence into a darkness from which, on a summer midday, the sky is a narrow strip of blue high above. The river at the bottom is cold, fed by the snow melt of the Alps, and dark, carrying suspended sediment from the highlands, and it has been carving this gorge deeper by perhaps a centimetre per century for the last 1 million years. That is the scale of geological time. A centimetre per century, maintained for 1 million years, produces 100 metres of additional depth, and the Rhône has been working for longer than that. The gorge is a reminder that the planet is patient, in a way that nothing alive can fully comprehend. Along the rim of the sink, the ecology is more familiar. The drying of the Mediterranean climate, amplified by the absence of the sea's moderating influence, has pushed the forest back and widened the zone of dry shrubland and grassland that borders the canyon edge. But the rivers bring moisture, and in their immediate valleys a corridor of green persists. Trees that can reach the water table survive, willows and poplars along the river banks, drought-resistant oaks on the slopes above, and below these the mixed scrub of a landscape that is not quite desert, but not quite anything else, a boundary zone that is one of the most productive edge habitats in nature. Edge habitats are where evolution works fastest. the boundary between two different ecosystems, where organisms from each must compete and cooperate, and sometimes merge, is where novelty emerges. The edge of the Mediterranean sink, that long rim running from the Atlantic coast of Morocco and Spain all the way around to the Levant and back through North Africa, is the longest unbroken edge habitat in the history of the terrestrial world. It runs for more than 15,000 kilometres, continuous, and it is alive with the ecological tension that produces new species. We will return to those species in time. But first, we need to go south to Africa, because something is happening there that will matter more than anything else in this story. 3 million years ago, in the world where the Mediterranean never refilled, the African continent is beginning to feel the absence of the sea in ways that go far deeper than geography. The Mediterranean Sea in our timeline is a climate engine of remarkable efficiency. Because of its shape, enclosed by land on almost all sides, its surface evaporation feeds directly back into the surrounding regions as precipitation. The winter storms that bring rain to North Africa, to the Levant, to the Italian peninsula, and the Balkans and southern France, are driven substantially by moisture that evaporates from the Mediterranean surface. Remove the sea, and you remove that moisture source. The winter storms still come, driven by the Atlantic weather systems that push eastward across Europe, but they have less water to carry, and they drop less rain as they go. The effect on North Africa is severe. The coastal belt of Morocco and Algeria and Tunisia and Libya, which in our timeline receives enough winter rainfall to support agriculture, receives significantly less in our alternative world. The Sahara, which in our timeline is held back from the coast by the narrow strip of Mediterranean climate, begins to press northward. The zone of semi-aridity widens. The forests that once grew on the northern slopes of the Atlas Mountains thin and retreat to higher elevations. The rivers that drain northward from the Atlas into what would have been the sea, finding instead the rim of the sink and plunging over it, run drier each year as their catchment areas receive less rain. East of Libya, the effect compiles further. Egypt, which in our timeline receives almost no rainfall outside the narrow Mediterranean coastal strip and depends entirely on the Nile for its fresh water, receives even less in our alternative. The eastern Mediterranean climate zone, which in our timeline moderates the Levant and the northern coast of Africa, does not exist. The Sinai is drier. The hills of ancient Canaan are drier. The eastern arc of the Fertile Crescent, which in our timeline supports the earliest cities of human civilization, is in our alternative a marginal, drought-stressed landscape of scattered scrub and seasonal watercourses. But the most consequential effect of the missing sea is not in the north of Africa. It is further south, in the regions that are, in our timeline, the birthplace of our species. The drying of North Africa is not contained at the Sahara. The atmospheric circulation patterns that carry moisture to the Ethiopian highlands and the East African lakes and rift valleys are connected to the larger climate system of the Mediterranean and the North Atlantic. They do not respond in isolation to the changes happening further north. The long-term drying trend that characterized the Pliocene and Pleistocene in our timeline, the gradual opening of the East African savannas and the retreat of the forests is amplified in our alternative world by the additional drying influence of the missing sea. The forests of East Africa thin, the savannas widen, the grasslands that in our timeline expanded gradually through the Pliocene, creating the open country environment in which our ancestors walked and ran and eventually thought expand faster and more completely in ours. The selective pressure on anything living in that landscape intensifies. Around 4 million years ago, in the actual world, the genus Australopithecus was walking upright across the East African savanna. We know this from the fossils, from the footprints preserved in volcanic ash at Lutoli in Tanzania, dated to 3.66 million years ago, from the bones of Australopithecus afarensis recovered from the Hadar region of Ethiopia. These were small creatures between 1 and 1.5 meters tall, with brains somewhat larger than those of modern chimpanzees, but nowhere near the size of what would come later. They walked on two legs. They used their hands for purposes other than locomotion. They lived in groups. They ate a varied diet that included both plant material and whatever animal protein they could obtain. In our alternative timeline, the ancestors of these creatures face a landscape that is drier, more open, more demanding than the one they faced in reality. The forests they had been retreating from for millions of years have retreated further, faster. The savanna stretches wider. The patches of woodland where a creature might hide from a predator, might find fruit, might shelter from the midday sun, are smaller and further apart. Whether this makes the evolution of intelligence faster or slower, whether it drives a lineage toward high cognitive function or simply toward extinction, is not a question that can be answered with certainty. Evolution is not a machine with a single output. The same pressure applied to different populations under different conditions produces different results. What we can say is that the conditions are more extreme, the selection more intense, and the landscape more demanding than what actually existed. Something is walking upright across the East African savannas in our alternative world 3 to 4 million years ago. Whether it is recognizably ancestral to us, whether it is on a path toward anything we would call human, is one of the great uncertainties that lives at the heart of this thought experiment. We will return to it, but for now, it is enough to note that the creatures who will eventually matter most to the story of our alternative world are already walking, already looking out across a wider and more demanding landscape than their counterparts in the actual world, and already beginning to change in response to it. Meanwhile, on the land bridge between Africa and Europe, the faunal exchange that should have ended when the Mediterranean refilled is still ongoing. The bridge is permanent now, and animals have been crossing it for 1 million years in both directions. The landscape of what would have been the western basin between Gibraltar and Sicily is a complex mix of salt flat and river delta and canyon rim and low hill, a mosaic of habitats that supports a surprising diversity of species. From Africa, the elephants have moved north, not the modern African elephant, which did not yet exist in this form, but the ancestral mastodons and their relatives, whose lineage had diversified through Africa during the Miocene. These are large, intelligent, social animals, and in our alternative world they find the canyon rims of the European sink, edged to be rich in food and water. They follow the rivers. They descend carefully into the upper reaches of the gorges, where the shade is permanent and the vegetation lush. They leave their footprints in the canyon mud, to be preserved there for millions of years, never to be found by anyone, because the people who would find them have not yet evolved. From Europe, other species move south, the ancestors of the lions and leopards and hyenas that in our timeline are thought of as quintessentially African actually have complex histories involving both continents, and in our alternative world, with a permanent land bridge encouraging movement in both directions, that complexity increases. Predators from the cooler European regions establish themselves in the more sheltered canyon systems of the North African rim, adapting to the extreme temperatures with behavioural strategies rather than physical ones, moving at night, sheltering by day, becoming crepuscular and nocturnal in a way that their European relatives never needed to be. The world at 3 million years before our present day, in this alternative timeline, is already radically different from the actual world at the same period. The difference is not the kind that would be immediately obvious from a distance. The same continents exist in the same positions. The same mountains have risen driven by the same tectonic forces. The same glaciers are beginning to form at high latitudes as the global climate cools into the Pleistocene. But the detail of the world, the ecology and the climate, and the movement of species and the carving of landscapes, is different in ways that compound with every passing generation. The Mediterranean sink has been there for 2.5 million years now, and it has begun to shape everything around it. The rim civilizations of the future, if any civilization comes, will inherit a geography unlike anything in the actual history of our world. They will live beside the greatest chasm on earth. They will know the wind that rises from the sink floor in spring, warm and mineral-scented and strangely electric. They will build their first villages at the edge of canyons so deep that the sound of the river at the bottom reaches them only as the faintest murmur, lost in the depth. If they build villages at all, that question is still open. And it will remain open for another 3 million years. 2.5 million years ago, something changes in the rhythm of the Earth's climate that is unrelated to the Mediterranean, unrelated to Africa, unrelated to any of the things we have been watching unfold in our alternative world. It is a change in the behaviour of the planet's orbital cycles, a shift in the way the Earth wobbles and tilts as it moves around the Sun, and it triggers an era of repeated glaciation that transforms every continent on Earth. The Pleistocene Ice Ages begin. In our actual timeline, the Ice Ages are one of the most formative influences on the world as we know it. They sculpted the landscapes of the northern continents, carving the valleys and fjords and moraines that define the scenery of Scandinavia and Scotland and the Great Lakes region of North America. They drove the evolution of the great cold-adapted megafauna, the woolly mammoths and woolly rhinoceroses and cave bears and giant ground sloths that we know from paintings on cave walls and bones in permafrost. They forced our own ancestors into cycles of expansion and contraction that may have driven some of the most rapid evolutionary change in hominin history. In our alternative world, the Ice Ages happen just the same. They are not caused by the Mediterranean, and they are not prevented by its absence. The same shifts in the Earth's orbital parameters drive the same expansion and contraction of ice sheets across the northern latitudes. The same cycles of cold and warm, glacial and interglacial repeat on the same roughly 100,000-year rhythm, but their effect on the Mediterranean sink and the surrounding regions is different from their effect on the actual Mediterranean coast. And that difference matters. In our actual timeline, the Ice Ages caused sea level to drop dramatically during glacial maxima, as enormous volumes of water were locked up in the expanding ice sheets. Sea level fell by as much as 120 metres during the last glacial maximum, approximately 20,000 years ago. This exposed the continental shelves, connected Britain to continental Europe, exposed land bridges between Alaska and Siberia, and generally rearranged the coastlines of every ocean in the world. In our alternative world, there is no sea in the Mediterranean basin to respond to these sea level changes. The sink is already below sea level by several kilometres. The Ice Age sea level falls, dramatic as they are, make no difference to the geography of the sink itself. They do not expose or flood any new land within the basin. They do not create or destroy the land bridge between Africa and Europe, because that bridge is already there and has been there for 2 million years. What the Ice Ages do to the sink is something different. They change the climate of the surrounding rim. During glacial maxima, the great ice sheets advancing from Scandinavia and from the Alps push the climatic zones of Europe southward. The tundra advances to latitudes that in our world are occupied by temperate forest. The forest retreats. The cold, dry air of the glacial period sweeps across the landscape that would have been the Mediterranean coast, carrying dust and sand from the exposed continental shelves and the drying grasslands. In our actual world, the Mediterranean Sea acts as a buffer during glacial periods. Its thermal mass moderates the temperature of the surrounding regions. Its evaporation continues to supply moisture even during glacial maxima. The Mediterranean climate zones shift and compress, but they do not disappear entirely because the sea is still there. In our alternative world, there is no buffer. The cold of the glacial maximum reaches further south and hits harder. The rim of the sink, already drier than the actual Mediterranean coast by the absence of the sea's moisture supply, becomes genuinely frigid during glacial maxima. Not Arctic, not glaciated, but cold enough that the plants and animals of the rim must either adapt, migrate, or die. The Great Canyon systems become, during glacial maxima, the most important refugia in the entire region. The canyon walls shelter the floor of the gorges from the worst of the cold. The rivers, fed by the snow melt of the mountains above, continue to flow even when the surface of the rim is gripped by frost. The thermal mass of the deep rock walls keeps the lower reaches of the canyons above, freezing even on the coldest nights. And so the species that survive the ice ages in our alternative world are those that have learned to use the canyons, to descend into the shelter of the gorge when the rim becomes uninhabitable, and ascend again when the climate warms. This vertical migration, up and down the canyon walls with the seasons and with the longer cycles of glaciation, is a new kind of ecological pattern that has no direct parallel in the actual world. The closest analogy is the altitudinal migration of mountain species, moving up in summer and down in winter, but the scale is different. The canyons of the Mediterranean sink are deeper than any mountain range, and the temperature gradient from rim to floor is steeper than any altitudinal gradient on a real mountain. The species adapted to this system are extreme specialists, capable of tolerating conditions that would kill most of their relatives. Among the species making this vertical migration are, by now, the ancestors of the intelligent beings that might one day ask the questions we are asking tonight. But that story requires its own chapter. For now, let us stay with the landscape itself and follow the great canyon systems of Europe through their Ice Age history. The Rhone Canyon in southern France reaches its maximum depth sometime around 1 million years ago in our alternative world. After that, the pace of down cutting slows as the river approaches a kind of equilibrium with the hardness of the rock it is cutting through and the volume of water it receives. The canyon at this point is approximately 2,200 meters deep from rim to river. Its walls are a geological encyclopedia, each stratum a different chapter of European history. At the top, the youngest rocks, limestone and sandstone, laid down in warm shallow seas long before the Mediterranean existed. Lower down, older sedimentary rocks, some bearing fossils of creatures that lived before the first dinosaur. And at the very bottom, where the river churns through the permanent darkness of the deepest gorge, ancient metamorphic rock that was once the root of a mountain range that no longer exists anywhere above ground, ground down and exposed by 4 million years of relentless erosion. The canyon walls support a vertical ecosystem of astonishing complexity. At the top, in the zone that receives full sunlight and is exposed to the rim climate, whatever scrubland and grassland characterizes the interglacial periods of southern France. 100 meters down, where the walls begin to shade the floor for part of the day, a belt of drought-resistant trees clings to the ledges. 200 meters down, where the temperature is moderated by the canyon's thermal mass and moisture condenses on the rock at night, a richer community of ferns and mosses and shade-tolerant plants fills every crack. 500 meters down, where sunlight reaches the floor for only a few hours even at midsummer, a community of organisms adapted to permanent semi-darkness survives in the zone of perpetual cool. And at the bottom, where the river runs cold and fast over polished boulders, a riverine ecosystem not entirely unlike what you would find in any European mountain stream, but stranger, adapted to the unusual light regime and the mineral-rich water flowing in from the evaporate-rich basin upstream. The Nile Canyon in Egypt is, by 1 million years ago, the deepest river gorge on Earth. At its maximum, near what will one day be the outskirts of Cairo, it descends more than 2,400 meters from the plateau above to the river channel below. It is wider than the Rhone Canyon, more arid on its walls because the Egyptian climate even at the rim is drier than the French climate, and its fauna is adapted to the extreme heat that the canyon intensifies rather than modulates. The Nile itself, at the bottom of this canyon, is a remarkable river. It carries an enormous volume of water, fed by the Ethiopian highlands and the East African lakes, and it has been cutting into the limestone and sandstone of the Egyptian plateau for millions of years. Its water is brown with sediment, laden with the minerals dissolved from the rocks it has crossed. Where it meets the hypersaline remnant of the Eastern Sphinx Lake system, in a vast, complex delta built up at the base of the canyon over millions of years of deposition. The mixing of fresh water and brine creates a gradient of salinity and nutrient concentration that supports one of the richest biological communities in the entire sink. This Nile Delta at the base of the canyon is not the broad, flat, fan-shaped delta of our actual world, built out into the sea at the level of the sea floor. It is a different kind of structure entirely. It is a deep canyon delta, built in stages down the walls of the gorge and across the floor of the basin below, a complex system of channels and floodplains and brackish lagoons, stacked vertically like the floors of a building rather than spread horizontally like the pages of a map. The productivity of this system in the wet seasons when the Nile floods are strongest is extraordinary. Nutrients from the Ethiopian highlands dissolve minerals from the canyon walls, fresh water mixing with brine to create every possible salinity gradient, and sunlight reaching the lower canyon in winter when the sun is low enough to penetrate the gorge. In our actual world, the Nile Delta of Egypt became the breadbasket of the ancient Mediterranean world, the agricultural foundation of Egyptian civilization. In our alternative, the deep canyon delta at the base of the Io Nile Gorge is perhaps the most biologically productive place in the entire sink system, a concentration of life and nutrients and ecological complexity in an otherwise extreme and demanding landscape. Creatures have learned to follow the Nile cycles. They descend the canyon when the floods bring nutrients and fresh water. They retreat up the walls when the floods recede and the brine levels rise in the delta. This vertical movement, repeated every year with the flood cycle and every 100,000 years with the glacial cycles, has been shaping the evolution of the species that use the canyon for millions of years. Among those species, by the time we reach the Pleistocene, are some that we would, if we could see them, recognize as at least remotely familiar. The ecology of the Mediterranean sink's rim, by 1 million years before our present day, is unlike anything in the world we know. The landscape is defined by the canyon systems, by the long edge of the escarpment, where the plateau drops away into the basin, by the rivers that thread down the gorge walls and build their deltas at the bottom, and by the vast horizontal salt flats of the deep basin floor, visible from the rim on clear days as a white glimmer in the extreme distance. Along this rim, 1,000 kilometers long, running from the Atlantic coast of Morocco, around the curve of what would have been the French coast and down through Italy and Greece and Turkey and the Levant, a community of large mammals has been evolving for 2 million years under conditions that have no parallel in the actual world. The herbivores are, by now, significantly different from any species that exists in reality. The elephantine creatures that walked north from Africa along the land bridge of the Western Sink 2 million years ago have continued to evolve on the European rim. They are larger than their African ancestors, consistent with the general tendency of large mammals to increase in body size in cooler climates. Their skin is more heavily wrinkled and folded, providing more surface area for heat dissipation during the warm seasons and trapping a thin layer of insulating air in the folds during the cold seasons. Their trunks are longer and more muscular, adapted for reaching the vegetation that grows on the canyon ledges below the rim. These are not woolly mammoths. The woolly mammoth of our actual world was adapted to the cold steppe environment of northern Eurasia, to feeding on frozen ground grasses and willows and sedges in temperatures far below freezing. The rim elephants of our alternative world face a different challenge. They must survive both the cold of glacial maxima and the heat of interglacials in a landscape that is always drier than any elephant in our world inhabits. They have evolved behavioural strategies for this. Seasonal migration along the rim, following the temperature gradient north and south, descent into the upper reaches of the canyon systems during the worst of the summer heat, sheltering in the shade of the gorge walls, use of mineral-rich springs that emerge from the canyon walls, licking the salt from the rock faces to supplement a diet that is always deficient in sodium by comparison with the diets of their coastal counterparts in our actual world. The predators that follow these elephants are also different. In our actual world, no predator regularly hunts adult elephants. The animals are simply too large, too dangerous, too well protected by their social structure for individual predators to tackle. But in our alternative world, the canyon system creates hunting opportunities that the open plains of Africa do not. The canyon walls and ledges, the narrow corridors between rock outcrops, the confined spaces of the upper gorge where a large animal has limited options for escape. These are ambush environments that a sufficiently intelligent and cooperative predator can exploit. And here we arrive at one of the most interesting evolutionary stories of the alternative Mediterranean world, because the predators that have been evolving along the Sink Rim for 2 million years are not wolves or lions or any of the canid or felid lineages that dominate the predator guild in the actual world's temperate zones. They are something else, something that traces its ancestry to the primates of East Africa, that walked north along the land bridge 1.5 million years ago, that found in the canyon system of the Rim a niche, unlike any that existed in their original homeland. They are bipedal. They are social. They make tools, or at least use objects as tools in ways that tool use in the actual world's primates has long been recognized as the beginning of. They communicate through a complex system of vocalizations that varies between groups and has been elaborating over thousands of generations into something that functions in a rudimentary sense, like language. They are not us, but they are the most cognitively complex animals alive in the alternative world, and they have been shaped by the most cognitively demanding environment that has ever existed on the surface of this planet. The rim of the Mediterranean Sink is an extraordinary place to evolve intelligence. The canyon system presents a three-dimensional puzzle of routes and resources and dangers that requires spatial reasoning of a high order. The seasonality of the rim environment, the extreme swings between interglacial warmth and glacial cold, between wet winters and dry summers, between the productive spring and the lethal summer, demands planning and memory, and the ability to anticipate conditions that are not yet present, but are reliably coming. The social structure required for cooperative hunting in the canyon environments, for the complex negotiations of territory and resource sharing that keep a group alive along the rim, demands social cognition, the ability to model the mental states of other individuals, to anticipate their behavior, to manipulate their actions through communication and deception. These are precisely the cognitive demands that drove the evolution of human intelligence in our actual timeline. The specific pressures are different, the landscape is different, the origin point is different, but the direction of selection toward intelligence, toward social complexity, toward communication and planning and tool use is not so different after all. The creatures of the Sink Rim are not on a guaranteed path to civilization. Evolution makes no promises. The intelligence that has developed among the canyon hunters of the Rim could plateau, could reverse under different conditions, could be cut short by any of the countless random events that end evolutionary lineages before they reach whatever potential the observer imagines for them. But the potential is there. By 1 million years before our present, there are creatures living along the rim of the Mediterranean Sink who are capable of passing knowledge between generations, who maintain complex social hierarchies that persist across multiple lifetimes, and who use the rocks and sticks and bones of the canyon environment as extensions of their own physical capabilities. They hunt cooperatively, these canyon dwellers. They coordinate attacks on the rim elephants that are among the most dangerous prey animals on Earth. Some individuals drive the prey toward the canyon edge, while others wait in the shadows of the upper gorge, and when the elephant stumbles on the loose rock near the rim, the waiting hunters are already moving. It is not always successful. The canyon floor has absorbed the bodies of hunters killed in these attempts for hundreds of thousands of years, but the hunts that succeed provide calories enough to sustain a group through a lean season, and they may also provide something less tangible, the social cohesion that comes from a shared dangerous experience and a shared difficult success. At night, around whatever fire they have learned to maintain, the canyon hunters of the rim do something that no other animal in the alternative world does. They make sounds that are not purely reactive. They produce sequences of vocalizations that serve no immediate practical purpose. that are not warnings or threats or mating calls, but that seem to encode information about events that are not currently happening, events that happened yesterday or might happen tomorrow. They are telling stories, whether those stories constitute language in the full sense that we use the word for human speech, whether they involve the kind of recursive grammar and abstract symbolism that characterizes human language, is a question that would require a linguist to answer, and there are no linguists yet in either our timeline or theirs. But they are something. They are the beginning of something. They are the cognitive foundation on which everything that follows, or might follow, will be built. The sink itself, in these same years, is continuing its slow work. The salt deposits on the floor of the eastern basin have now been accumulating for over 4 million years. The mineral concentration is unlike anything that exists on Earth in our actual world. Potassium salts that are the essential ingredient of agricultural fertilizer, gypsum in quantities that would dwarf any deposit currently known, sodium chloride in a layer thick enough to supply the entire human demand for salt for millions of years, all of it just sitting there, in the deepest part of the driest desert on Earth, untouched and unnamed. The canyon systems are now, by any reasonable measure, the most dramatic surface features on the planet. The Roan Gorge at its deepest is 20% deeper than the real Grand Canyon. The Nile Gorge at its deepest is more than twice the depth of the real Grand Canyon. The gorges of the smaller rivers, the Ebro and the Po and the Chelif and the rivers of Turkey and the Levant, are individually less impressive, but collectively constitute a canyon landscape of staggering extent, running almost continuously along the 15,000-kilometre perimeter of the sink, and along the rims of these canyons, in the canyon walls themselves, in the delta systems at the canyon floors, in the transition zones between the rim scrubland and the canyon vegetation, in every ecological niche that the extraordinary three-dimensional landscape offers. Life has been quietly filling the available space, as it always does, as it has done since the first cell divided in some ancient ocean, before any of this landscape existed. The Mediterranean sink is not a dead world. It never was. It is a world unlike any other in the history of the earth, shaped by forces and on a time scale that have no parallel, and it is alive in every part of it that life can reach, which turns out to be quite a large part. 500,000 years ago, something remarkable has been happening along the rim of the Mediterranean sink for long enough that it has begun to look permanent. The canyon hunters, those bipedal, social, tool-using creatures that trace their ancestry to the primate populations of East Africa, have spread along the entire perimeter of the sink. They occupy every major canyon system from the gorges of Morocco in the west to the deep cuts of the Levant in the east. They have crossed the land bridge between Africa and Europe not once, but many times, in both directions, following game herds and seasonal food sources, driven by population pressure from their own growing numbers. They are not a single species. They have not been a single species for hundreds of thousands of years. The different populations, separated by the vast distances of the rim perimeter and by the formidable barriers of the deep canyon systems that periodically interrupt the rim's continuity, have been diverging genetically for as long as they have been separated. The canyon dwellers of the Roan Gorge are measurably different, in bone structure and brain volume and behavioural repertoire, from the canyon dwellers of the Nile Gorge. They are not so different that they cannot interbreed when populations meet, which they do occasionally, at the land bridges and at the navigable sections of the rim, but they are different enough that a careful observer would note the distinction. Several branches of this family, several experiments in intelligence, running simultaneously in different parts of the rim landscape, under somewhat different conditions. This is already different from what actually happened. In our actual timeline, the emergence of high intelligence was, as far as we can tell, a single event. One lineage, in one part of Africa, made the critical transition to the kind of cognitive complexity that produces language and culture and eventually civilization. Other intelligent lineages, The Neanderthals and the Denisovans, and perhaps others whose remains have not yet been found, existed alongside our ancestors for a time, but they did not survive. Only one lineage produced what we are. In our alternative world, the pressures are more widespread, the opportunities more numerous, the landscape more varied. The result is not one lineage making a single transition, but several lineages in different places, making parallel and partially overlapping transitions at different speeds and in different directions. Whether any of them make the full transition, whether any of them cross the line from impressive animal intelligence to the kind of recursive, symbol-manipulating, future-projecting cognition that we call human level, is still uncertain at the 500,000-year mark. But the trajectory is clear, the direction is clear. The question is not whether something interesting is happening, but whether it will reach the threshold that matters. To understand why the threshold matters, we need to talk about what intelligence actually is, and what it is not. There is a story told in countless documentaries and popular science books about the progression of intelligence as a kind of inevitable march from simpler to more complex, from animal to human, from instinct to reason. This story has a satisfying narrative shape. It implies that intelligence is what evolution was working toward all along, that our existence is in some sense the point of the whole enterprise. This story is wrong, or at least it is incomplete in ways that matter for what we are imagining tonight. Intelligence, in the sense of the cognitive complexity that allows for planning and tool use and social manipulation, evolved many times in the history of life. It evolved in crows and parrots and octopuses and cetaceans, in lineages so different from our own that the parallel evolution of sophisticated cognition in each is one of the most striking facts in all of biology. Crows can plan for future contingencies that have not yet occurred. Octopuses can solve novel problems without any prior experience relevant to those problems. Dolphins appear to maintain complex social networks with something like personal identity and long-term social memory. None of these animals built cities. None of them developed writing or mathematics. None of them is in any danger of doing so, even given millions more years to evolve. The reason is not lack of intelligence, in some meaningful sense. The reason is the specific combination of circumstances required for the kind of cultural accumulation that produces civilization. You need intelligence, yes, but you also need hands capable of precise manipulation. You need a social structure that allows knowledge to be transmitted and built upon across generations. You need a sufficiently stable environment that allows populations to grow large enough for specialization to occur. And you need, crucially, something like language, a system of communication rich enough to encode not just immediate experience, but abstract concepts, counterfactual scenarios, instructions that can be followed by someone who was not present when they were developed. The canyon hunters of the Sink Rim have some of these prerequisites. They have intelligence, they have hands, they have social structures that transmit knowledge across generations. They have something like language. What they may lack at the 500,000-year mark is the stable, productive environment that allows population densities to rise high enough for genuine cultural specialization to emerge. The rim of the Mediterranean sink is a demanding environment. It is not uniformly productive. The glacial maxima periodically devastate the rim populations, forcing them into the canyon refugia and reducing their numbers dramatically. The interglacials allow recovery, but the recovery is always partial, always interrupted by the next cold phase. The population oscillations are too extreme, and the environment too unstable over the 100 to 1,000-year cycle for the kind of sustained demographic growth that in our actual world allowed human civilization to emerge after the end of the last ice age. In our actual world, the key transition happened when the ice ages ended, approximately 12,000 years ago, and a prolonged period of climatic stability allowed the populations of the Fertile Crescent and the Nile Valley and the Yangtze Basin to grow large enough that some individuals could afford to stop hunting and gathering and start doing other things. That specialization, that division of labor, that ability to accumulate surplus and trade it, and build on it across generations, is what produced civilization, not intelligence alone. Stability plus intelligence plus communication plus a large enough population plus an accident of geography that put cultivable wild grasses in the same place as the right kind of social animals. In our alternative world, several of these conditions are in place, but the stability is not. The canyon rim environment oscillates too violently between productive and barely habitable. The population of intelligent beings along the rim is never large enough, sustained for long enough, to produce the critical mass of cognitive specialization that tips a society from sophisticated hunter-gatherer into something else. But then, about 200,000 years ago, something happens that changes the equation. The last major glaciation before our present day begins, and it is more severe than most of its predecessors. The ice advances further south. The rim populations are compressed into smaller and smaller refugia. The pressure is intense. And in the canyon systems of the eastern rim, in the deep gorges of the Levant and the upper reaches of the Nile Canyon, where fresh water and shelter and food are concentrated by the geography of the gorge, something begins to shift in the behavior of the canyon hunters. They stop moving as much. Not permanently, not entirely. The seasonal migration continues, but the groups that use the deep canyon refugia during the glacial maximum begin to stay longer in the canyon valleys and shorter on the rim above. They develop more elaborate shelters in the canyon walls, using the natural alcoves and overhangs of the gorge as semi-permanent homes. They begin to manage the resources of the canyon more deliberately, replanting roots they have dug up, maintaining the springs that provide fresh water, choosing not to overhunt the prey species that use the same refugia, because they have learned, not through conscious planning but through the slow feedback of consequences, that the canyon ecosystem is more productive when its animal populations are healthy. This is not agriculture. It is not even proto-agriculture in the sense that the term is usually used. But it is resource management. It is the behavioral precursor of the relationship between a human population and its landscape that eventually leads to cultivation and herding and all the rest of it. The canyon hunters of the Levant Gorge, 200,000 years ago in our alternative world, are smarter than any non-human animal alive in the actual world at any point in its history. They are as smart, perhaps, as a very capable member of our own species would be if raised without language or culture or any of the tools of civilization, relying purely on evolved cognitive capacity. They are making decisions that look, to a careful observer, like strategic planning. They are teaching their young in ways that go beyond simple imitation, that include something recognizable as explanation, as the transmission of causal reasoning rather than just behavioral templates. Whether they cross the threshold into true language, into the kind of symbolic communication that allows for the transmission of complex abstract ideas, is a question that cannot be resolved by the evidence available in our thought experiment. The honest answer is that we do not know. The cognitive architecture may be in place, the social environment may be demanding enough, but the threshold has not been crossed yet, and whether it is crossed at 200,000 years ago, or 20,000 years ago, or at all, is genuinely uncertain. What we can say is that the world where the Mediterranean never refilled is not a world without intelligence. It is a world where intelligence evolved under different pressures, in different forms, distributed along the rim of a desert, rather than concentrated in the river valleys and coastal plains of the actual world's most productive regions. Whether that distributed, canyon-adapted intelligence finds its way to civilization, whether it produces writing and agriculture and cities and eventually the kind of being that lies awake asking questions about alternative timelines, is the most important open question in our entire alternative history, and it is a question we cannot answer. We can only follow the world forward and see what the landscape of our present day would look like if no one, or no one quite like us, was there to look at it. Stand on the rim of the Mediterranean sink in the equivalent of our present day, approximately 5.33 million years after the flood that never came, and look down into the basin. The view is not like anything in the world you know. The closest analogy available in the real world is perhaps the edge of the Grand Canyon, but the Grand Canyon is a modest feature by comparison. The Grand Canyon is 1.6 kilometers deep. The rim below your feet, if you are standing above what would have been the deepest part of the Ionian Basin, falls away for more than 4 kilometers. The far wall of the basin, if there is a far wall visible, is more than 1,000 kilometers away. What you're looking at is not a canyon. It is a different world, a world below the world, visible from above but unreachable by any ordinary means. The floor of the deep basin, in our current moment, is covered by approximately 5 to 6 kilometers of accumulated evaporates. Salt and gypsum and anhydrite and potassium compounds and hundreds of other mineral species, laid down year by year for 5.3 million years, compressed by their own weight into a hard crystalline mass. On top of this mineral layer, a thin veneer of wind-blown dust and whatever has fallen from the canyon walls and river deltas over the millennia. And on that veneer, in the spring and autumn windows, when temperature and humidity allow, the microbial life that has persisted in the sink's deepest refugia since the original desiccation. The basin floor is not a pleasant place. In summer it is lethal. In winter it is cold and dark at the base of the canyon walls, where the sun reaches only for a few hours around midday. In the brief spring and autumn windows it is merely extreme, a landscape of blinding white and complete silence and air so dry that moisture evaporates from exposed skin in minutes. But it is not dead. It has never been dead. And now, 5 million years into the alternative timeline, the ecology that has built up along the canyon walls and in the transition zones at the base of the gorges is a complex, layered, deeply adapted system that has no parallel anywhere in the actual world. The rim, by contrast, is alive in the way that any dry country landscape is alive. The absence of the sea has made the climate of the Mediterranean rim drier than the actual Mediterranean coast, but it has not made it uninhabitable. The rivers still flow, the winter rains still come, driven by Atlantic weather systems. The soil where rivers and springs keep it moist still supports vegetation. What has changed is the character of that vegetation, the character of the animals that live in it, and the relationship between the rim ecosystem and the extraordinary vertical landscape below it. The permanent land bridge between Africa and Europe, operating for 5.3 million years, has thoroughly mixed the faunas of two continents that in our actual world remain substantially separated until the closure of the Tethys Sea, and even after that were isolated by the Mediterranean. The result is a megafauna of extraordinary diversity, combining elements from both continents in combinations that have no parallel in the actual world. Large proboscideans evolved from the ancestral mastodon lineages that crossed the land bridge early in the alternative timeline, are the dominant large herbivores of the rim. They are not identical to any elephant that has existed in our world. They are larger, more cold adapted in their northernmost populations, more heat adapted in the southern populations, and more behaviourally sophisticated than any elephant in our timeline as a consequence of 5 million years of evolution in the demanding canyon environment. They use the canyon walls. They know the seasonal rhythms of the gorge in detail. They teach their young the routes through the gorge systems that connect one section of the rim to another. Alongside them, descendants of the African bovids that crossed the land bridge 2 to 3 million years ago have diversified into dozens of species, filling the niches that in the actual world are occupied by the diverse artiodactyl fauna of Europe and Asia. Some are large and relatively placid, browsers in the canyon vegetation. Others are small and fast, grazers on the rim scrubland, relying on speed and vigilance for protection against the canyon predators. A few are remarkable for their adaptation to the vertical canyon environment, with hooves and musculature that allow them to move on slopes that would be impassable to any animal not specifically shaped by millions of years of selection for that exact challenge. The predators are the most cognitively interesting animals in the alternative world, because they are the ones for whom intelligence has provided the greatest selective advantage. The canyon environment rewards intelligence in predators more than almost any other ecological context. The three-dimensional landscape, the complexity of the hunting terrain, the dangerousness of the prey, the requirement for cooperative strategies, all of these things have pushed the predator lineages of the rim toward larger brains and more complex social behavior than their ancestors possessed. The canyon hunters, those bipedal hominins we met earlier in our alternative history, are the apex of this cognitive trend. By the equivalent of our present day, they are making shelters of stone and wood in the upper reaches of the canyon gorges. They are passing knowledge across generations, not just through behavioral example, but through some form of symbolic communication. Markings on canyon walls, objects arranged in patterns, vocalizations that encode information not directly present in the immediate environment. Whether this constitutes civilization, whether it has crossed the threshold into something we would recognize as distinctly human, is one of those questions that depends entirely on where you draw the line. If civilization requires cities and writing and agriculture, then no, the canyon hunters have not arrived there. If civilization requires the transmission of complex cultural knowledge across generations, the deliberate shaping of the environment to suit the needs of the population, and the social structures capable of organizing collective action for large-scale projects, then they are at the edge of it, standing on the rim of something larger than themselves, not quite ready to step forward. Or perhaps they stepped forward 10,000 years ago, and we are simply not there to recognize it. The oceans of the alternative world, meanwhile, are different from ours in ways that are subtle but significant. The global ocean circulation, which in our actual world is profoundly influenced by the outflow of the dense, salty Mediterranean water through the Strait of Gibraltar, functions differently without that contribution. The Mediterranean outflow in our actual world is a significant driver of North Atlantic circulation, contributing to the patterns of temperature and salinity that govern the climate of northwestern Europe. Without it, the North Atlantic circulation is somewhat different. The climate of Britain and Scandinavia is somewhat colder. The winter storms that cross the Atlantic are somewhat differently distributed. These are not catastrophic differences. The basic patterns of global climate are driven by the distribution of solar energy with latitude, by the location of the continents, by the Himalayas and the Rocky Mountains and the Antarctic ice sheets, none of which are different in our alternative, but the details are different, and the details of climate are often what determine whether a particular landscape is marginally habitable or genuinely productive. The rivers of Europe flow into the sink rather than into the sea. The Atlantic coast of Europe and Morocco is unchanged, because the Atlantic is unchanged. The North Sea exists, the English Channel exists, the Baltic exists. The North African coast beyond the narrow western arm of the sink's rim is the Atlantic coast of Morocco, identical to what it is in our actual world. But everything east of Gibraltar is the rim of the sink, and the rim of the sink, in the equivalent of our present day, is one of the most dramatic and biologically rich landscapes on the surface of the earth, home to the most cognitively complex non-human animals that have ever evolved, rich in mineral resources that have been accumulating for 5 million years, and perched on the edge of the deepest desert that has ever existed. Whether anyone is looking at it, whether anyone has the capacity to stand on that rim and think what a strange and beautiful and terrible world this is, remains the most important unanswered question in our alternative history. The answer probably depends on whether you count the canyon hunters as people. And that is a question that has no clean resolution in any timeline, actual or imagined. Africa in the alternative present is recognizable in its broad outlines but different in its details. The Sahara exists, driven by the same atmospheric dynamics that create it in our actual world. The Hadley Cell, and the position of the intertropical convergence zone and the rain shadow of the Atlas Mountains. But it is larger, because the drying of the North African coast without the Mediterranean's moderating influence has pushed the desert somewhat further north and made its margins somewhat drier. The Sahel is harder. The agricultural belt of Morocco and Algeria is narrower. South of the Sahara the landscape is more familiar. The East African savannas and rift valleys are similar to what they are in our actual world, because the factors that shape them, the rift geology and the altitude and the latitude, are the same. The Great Lakes are there. The Nile rises in the Ethiopian highlands and flows north, as it has always done, until it reaches the canyon that replaces its delta and plunges over the rim of the sink into the gorge below. The wildlife of East Africa, in our alternative world, is different from the wildlife of our actual East Africa in one significant way. It has not been hunted to fragmentation by any highly capable technological predator in our actual world. The great megafauna of Africa that survived the last ice age did so partly because it had evolved alongside human hunters for long enough to develop appropriate fear, responses and avoidance behaviours. The megafauna of other continents, encountering human hunters for the first time in the late Pleistocene, was devastated by a predator it had no evolutionary experience with. In our alternative world, if the canyon hunters of the rim have not achieved the technological and organisational capacity to hunt on a global scale, the megafauna everywhere is as abundant as it was at any peak point in the actual Pleistocene. Elephants in numbers that darken the landscape, giant bovids grazing in herds that stretch from horizon to horizon, predators in abundance, because the prey is abundant, a world teeming with large animals in a way that the actual world has not been for at least 50,000 years, and in some regions much longer. This abundance, if anyone is there to see it, would look like paradise, a world that our timeline has been trying to remember and recreate for decades through conservation efforts, achieving a pale fraction of what this alternative world simply has as its natural condition. The canyon systems of the European rim in our alternative present are the most visited places on Earth by the canyon hunters. They congregate in the most productive sections of the gorges, around the freshwater springs and the river deltas, and the sections of canyon wall that provide the best shelter from the summer heat and winter cold. Their populations are not large by the standards of actual human civilization. The carrying capacity of the rim environment, even after 5 million years of ecological development, is limited by the extreme conditions of the sink itself and by the oscillating climate of the glacial cycles. But they are there. They are alive. They are thinking about the things that intelligent animals think about, which is mostly immediate practical matters. The location of water and food and shelter, and the intentions of rivals and the welfare of their young. But occasionally, sometimes, in the canyon refugia, during the long nights of the glacial maximum, when there is nothing to do and nowhere to go, something else. Something that looks, from a sufficient distance, a little like wonder. There is a geological fact about the alternative Mediterranean sink that sounds, when you first encounter it, almost too large to hold in the mind. Every year that passes without the sea, the sink grows slightly more extreme, not dramatically, not in any way that would be visible over a human lifetime, or 10 human lifetimes, or even 100, but the salt layer on the basin floor is a millimetre thicker this year than it was last year, because the rivers still bring dissolved minerals and the sun still takes the water. The canyon walls are a fraction of a centimetre lower relative to the basin floor, because the rivers are still cutting, and the evaporates are still accumulating, and the isostatic balance between the weight of the mineral deposit and the buoyancy of the crust beneath it is still slowly adjusting. The creatures along the rim have produced a fraction of a generation, more of an evolution, since the last time we checked on them, and that fraction of a generation is slightly better, adapted to the conditions of the rim than the fraction before it. 5 million years of fractions add up to something enormous. To walk along the rim of the Mediterranean sink in the equivalent of our present day, if you could do it, would be to walk through the most concentrated record of geological and biological time that the surface of the earth has ever produced in one place. The canyon walls of the Rhone Gorge expose rock from 40 different geological periods, stacked in order from youngest at the top to oldest at the bottom, a library of Earth history that nowhere else in the world is so continuously and completely accessible. The canyon floor, and where the river runs over ancient metamorphic rock that predates the Alps, is a window into the deep Precambrian of Europe, into a time before any of the creatures alive on the rim had any ancestors recognizable as animals. The rim itself, the long escarpment running from the Atlantic coast of Spain and Morocco all the way around to the Levant, is perhaps the most biologically diverse edge habitat that has ever existed. The diversity comes from the combination of factors that always produces diversity in biology. A complex three-dimensional landscape offering many different niches, a stable but varied climate that rewards different strategies in different microhabitats, a long evolutionary time during which many lineages have had the opportunity to specialize, and the continuous input of organisms from two entire continental faunas mixing across the permanent land bridge. The number of large mammal species alive along the rim of the sink in our alternative present day is, by any reasonable estimate, 3 to 4 times the number alive in the actual Mediterranean region. The actual Mediterranean basin and its surroundings, in the real world, support a relatively impoverished megafauna by comparison with Africa or tropical Asia, a consequence of the repeated extinctions of the Pleistocene that were driven in part by the arrival of human hunters in regions where the animals had no prior experience with such efficient predators. In our alternative world where the canyon hunters are, if anything, smarter than the human hunters of the actual world, but exist in much smaller numbers, and without the technological multipliers that human civilization eventually produced, the megafauna has not been significantly depleted. The herds of large herbivores on the rim and in the canyon systems are as large as they were at the peak of the actual Pleistocene megafauna, perhaps larger. Consider what that means in concrete terms. Herds of large proboscideans moving along the rim in their seasonal migrations, families of a dozen or 20 animals, matriarch-led, with deep knowledge of the canyon roots encoded in the oldest females and passed to their offspring through observation and instruction. Moving north in spring as the rim vegetation greens after winter rain. Moving south in autumn before the rim becomes too cold, descending into the upper canyon sections where the temperature is moderated by the gorge, following routes that their ancestors established and that have been maintained by the continuous use of each generation for hundreds of thousands of years. Alongside them the grazing and browsing bovids in dozens of forms, filling niches from the high scrub of the rim plateau down through the canyon vegetation bands to the riverine forest at the canyon floor. Some of these are very large, occupying the ecological role that in the actual world is filled by the largest bovids of Africa and Asia. Others are small and swift, moving in tight, reactive herds that are their primary defense against the canyon predators. A few are extraordinary specialists, capable of descending into the middle reaches of the gorge along routes that no predator not specifically adapted for that terrain can follow, exploiting the canyon vegetation unmolested by anything, except the raptors that ride the updrafts above the gorge. The raptors are worth a moment. In the actual world, the Mediterranean and its surrounding regions support a diverse and impressive raptor fauna, eagles and vultures and falcons and hawks filling the aerial niche above a landscape of cliffs and open country and forest edge. In our alternative world, the updrafts from the heated basin floor create conditions for soaring flight that are more powerful and more persistent than anything in the actual world. The thermal columns rising from the sink floor in summer are extreme, carrying a large bird to high altitude with no effort at all, and the cliff faces of the canyon walls provide nesting sites in a density and variety that no actual cliff landscape can match. The result is an aerial fauna of extraordinary diversity and size. The largest soarers of the alternative rim are birds that exceed in wingspan anything that has existed since the Miocene, taking advantage of the exceptional thermals to carry body masses that would be impossible to support in flight anywhere with weaker lift conditions. They are not quite like any actual bird that has ever existed. They carry the basic avian body plan into dimensions that push against the physical limits of feathered flight, and they have done so by exploiting conditions that exist nowhere in the actual world. Beneath the raptors in the canyon walls and the transition zones between canyon and rim, the small and medium-sized vertebrate fauna of the alternative world is as diverse and as specialized as any comparable habitat system in the actual world. The canyon system has had 5 million years to develop its endemic species, those found nowhere else in the world because the specific combination of conditions that shape them exist only in the gorges of the Mediterranean sink. The canyon geckos with their specialized footpads adapted for the polished limestone of the lower gorge walls, the cave crickets of the deep shadow zones, where the sun reaches for only a few minutes each day, the blind salamanders of the underground streams that run through the soluble limestone of the canyon's middle levels. Endemism of this depth, species found in one canyon and no other, is usually a sign of a very old and very stable system. The Hawaiian Islands produce it through isolation. The deep caves of the Dinaric Alps produce it through the darkness that excludes competitors. The Mediterranean sink would produce it through the combination of isolation, extreme conditions, and the sheer depth of evolutionary time that the canyon system has been developing. The western basin of the sink, the area between Gibraltar and the Sicilian Ridge, has a somewhat different character from the eastern basin. It is shallower, its floor closer to sea level, and therefore less extreme in its temperature range. The rivers flowing into it from Spain and France are larger and carry more water than the rivers of the eastern rim, particularly in winter and spring when the Atlantic weather systems push precipitation deep into the Iberian and French hinterlands. The result is that the western basin floor during winter and spring receives more freshwater input and supports a more complex and productive ecology on its margins. The delta systems at the base of the Rhone and Ebro canyon systems are, in the alternative present, among the most productive freshwater to saline transition zones on Earth. The Rhone Delta, in particular, building outward across the western basin floor for millions of years of continuous deposition, has accumulated a complex layered landscape of saline flats and freshwater channels and brackish lagoons that extends for hundreds of kilometers from the base of the canyon. The ecological complexity of this delta is extraordinary, each of its many salinity zones supporting a distinct community of organisms, some found throughout the world's saline and freshwater systems, others found only here, in this unique place where a European river has been pouring over a cliff and building a delta at the bottom for 5 million years. The eastern basin, by contrast, is hotter and drier and more extreme in every respect. The Nile Canyon dominates the eastern rim, its enormous volume of fresh water creating a productive corridor from the highlands of Ethiopia all the way to the floor of the sink, but the canyon is so deep and so narrow at its lower reaches that the freshwater influence is concentrated in a relatively small area. Outside the Nile Canyon's reach, the eastern sink is the most extreme part of the alternative world's most extreme landscape, a salt desert 4 to 5 kilometers deep, receiving almost no freshwater input except from the small rivers of Turkey and the Levant cutting their own, smaller gorges down the eastern rim. The land bridge between Africa and Europe, through the western basin, has been the most ecologically important geographical feature of the alternative world for 5 million years. It is wide enough and varied enough in its terrain that it functions not as a narrow corridor through which species must pass one by one in single file, but as a broad complex landscape in its own right, with its own communities and its own endemic species, shaped by the peculiar conditions of a lowland basin that is below sea level but not flooded, connected to both continental faunas but dominated by neither. The land bridge has its own weather. Cold air from the northern rim descends into it in winter and pools there, creating temperature inversions that in some years produce frost on the basin floor, even though the basin floor is far below the level at which frost would normally occur at that latitude. In summer, the heating of the basin floor drives convection cells that draw in air from both the African and European sides, creating complex wind patterns that carry seeds and insects and spores from one continent to the other and contribute to the mixing of the two faunas that has been ongoing since the basin first dried. The minerals of the land bridge floor, those extraordinary concentrations of evaporites that have been building for 5 million years, are an important resource for the animals that use the land bridge. Many large herbivores have a specific need for sodium and potassium and other minerals that are difficult to obtain from a purely plant-based diet, and the salt licks of the land bridge floor, where the evaporites come close to the surface and are exposed by wind, erosion, or river scour, are important gathering points for these animals. The land bridge salt licks attract animals from both continents, and they are important meeting points for the canyon hunters of the rim, who have learned to intercept large herbivores at these predictable locations. The canyon hunters' knowledge of the land bridge salt licks and their ability to plan hunts around the predictable behavior of animals visiting them is one of the most sophisticated examples of the kind of cognitive complexity we have been watching develop along the rim. A hunt at a salt lick requires anticipating not just the presence of prey, but the timing of their arrival, the direction of their approach, the likely reactions to the presence of hunters, and the coordination of multiple individual hunters positioned at points around the lick that they must reach in advance and wait in. This is forward planning of a considerable complexity, executed in a social context that requires reliable communication and trust. It is also, we should be honest about this, probably not unique to the canyon hunters of the alternative world. There is evidence in the actual world that Neanderthals planned their hunts with comparable sophistication, that they positioned themselves at predictable animal crossing points and worked cooperatively to drive prey or wait in ambush. What the canyon hunters of the alternative world have, that the Neanderthals of the actual world may not have had, is a longer time in which this cognitive complexity has been developing, and a more consistently demanding environment that has maintained the selective pressure for it without the periodic relaxation of conditions that might have allowed cognitive complexity to stabilize at a lower level. The result is, by the equivalent of our present, a creature that is very smart. Smart enough to make us uncomfortable about the line between us and them, if we could see them, which we cannot. Smart enough that the question of whether they have crossed some threshold we regard as essential to humanity is not merely rhetorical, but genuinely difficult. And there is something almost poignant about that difficulty, about the fact that the question exists in our world only as a thought experiment, that the creatures who might answer it, or who might not know how to answer it, or who might ask their own version of it on the rim of their desert in the dark of their night, exist only in the space of imagination that the actual world makes possible. We are imagining them. They are not imagining us. We are the consequence of the flood. They are the consequence of its absence. And both of those things are real, in their different senses of the word. The alternative world has been alive for exactly as long as our world has. 5 million years of life in the sink. 4 billion years of life before the sink existed. The same long history of evolution and extinction and adaptation and novelty that produced our world's extraordinary diversity of living things. The canyon hunters are not a diminished version of us. They are a different result of the same evolutionary process, shaped by a different version of the same planet. They are as much the product of their world as we are of ours. This is the central thing to understand about alternative histories. They are not inferior to the actual history. They are not corrected versions of the actual history. They are other, which is a different thing entirely. Other does not mean lesser. It means shaped by other pressures, by other contingencies, by the specific outcomes of specific events that in any universe's full complexity of causes and conditions might have gone in any of 1,000 ways. The rock gave way. Everything followed. The rock held. Something else entirely followed. And the universe, with its characteristic indifference to our need for things to have been inevitable, contains both possibilities in the space of what might have been, and only one of them in the space of what is. You are living in the one that is. The other one lives only in the space of imagination that the actual world, through its improbable history, has managed to produce. That is a gift so strange and so complete that it takes the whole of a night to begin to feel the edges of it. Here is the strange thought to sit with. As the night deepens and the images of the alternative world begin to soften at their edges, the Mediterranean Sea exists in the world you are lying in right now because a piece of rock gave way. That is the whole of it. A barrier of rock, somewhere in the region of what is now southern Spain or northern Morocco. The exact location still debated among geologists who have spent their careers trying to find the scar of it, failed to hold against the pressure of the Atlantic. Or the Atlantic found a low point and trickled over. Or a combination of pressures, tectonic and climatic, opened a crack that the ocean widened into a channel, and the channel into a strait, and the strait into a flood that no remaining barrier could resist. The event took, at most, a few years, perhaps months, the largest flood in the history of the earth, and it lasted no longer than a good drought. Before that flood, the Mediterranean was a desert. After it, the Mediterranean was a sea. And the world that followed from that difference is the world you are in now. The world with Rome and Athens and Alexandria. The world with the dhows of Arab traders and the triremes of the Greeks and the galleys of the Phoenicians. The world where a sea route connected Egypt to Lebanon, to Turkey, to Italy, to Spain, and made the ancient Mediterranean not a barrier between civilizations, but the road between them. The world where the winter rains fell on the North African coast and made agriculture possible in a region where, without that sea, agriculture would have been enormously more difficult, or perhaps not possible at all. The world where you are here, lying in the dark, listening to someone ask what would have happened if things had gone differently. You are the direct consequence of that piece of rock giving way, not metaphorically, not in a distant and diffuse sense in which everything is caused by everything else and therefore everything is the consequence of everything, directly. The drying of North Africa without the Mediterranean moisture would have altered the evolution of the East African ecosystem, where your ancestors walked and hunted, and eventually began to think beyond the immediate moment. The absence of the Mediterranean would have made the Fertile Crescent significantly less fertile, might have prevented the development of the agriculture that allowed the population densities, that allowed the specialization, that allowed someone to sit down and think about mathematics and writing and philosophy without immediately having to get up and go find something to eat. The civilization that produced you and the intellectual tradition that makes it possible for you to wonder about counterfactual histories runs through the Mediterranean, through the Greek philosophy and the Roman law and the Arabic scholarship and the Italian Renaissance and the scientific revolution and all the rest of it. Every piece of that tradition was shaped by the sea, by the fact that ideas and people and goods could move across that body of water faster and more safely than they could move across the land, by the fact that the sea connected cultures that would otherwise have remained separate, and that the collision of cultures is one of the great engines of intellectual progress. All of that runs through the piece of rock that gave way. If the rock had held, none of it follows. Not necessarily because intelligence does not emerge, because we have seen that intelligence of some kind almost certainly does emerge in the alternative world, shaped by the canyon environment and the demands of the rim ecosystem, but because the specific path from intelligence to civilization, the particular sequence of conditions and accidents and collisions of cultures that produced your world, depended on the sea. This is not a small thing, it is perhaps the most important contingency in the history of your species. The canyon hunters of the alternative world, in the equivalent of our present day, are sitting somewhere on the rim of the Mediterranean sink, perhaps in the shelter of an overhang above the Rhone Gorge, watching the sun set over the western basin. The light at that elevation is extraordinary. The sky to the west is a gradient from pale yellow at the horizon to deep blue overhead, and the basin below, catching the last horizontal rays of the setting sun, glitters with mineral light. the salt crystals on the floor of the deep basin reflecting the red and orange of sunset like 1,000 scattered mirrors. They do not know the sun is setting on 5.3 million years of their world's history. They do not have that frame of reference. They know the sun is setting because they have watched it set from this spot, or spots like it, every evening of their lives. They know the colour means something about the weather tomorrow. They know the depth of the basin below them is greater than anything they can directly measure, because they have never reached the bottom on any descent they have made into the gorge. They know the mineral smell rising from the canyon on the warm evening air, and they know that smell differently depending on whether the wind is coming from the east or the west, and each variation of that smell tells them something about conditions in the part of the canyon the wind has crossed. They know their world, with the intimacy that comes from 5 million years of their lineage living in it. Not as a set of facts, not as propositions that can be stated and debated, but as an embodied knowledge, a knowledge that lives in the muscles and the reflexes and the unconscious pattern recognition of creatures shaped by this landscape over the deepest stretches of time. Whether they are conscious of any of this, whether there is something it is like to be them in the way that there is something it is like to be you, is a question that philosophy has not resolved even for beings much closer to our own kind than the canyon hunters. Consciousness is the hardest problem. We cannot even fully explain why you are conscious, why there is something it is like to lie in the dark and listen to a voice describe a world that never was. We certainly cannot say whether the canyon hunters of the alternative sink rim are conscious in any meaningful sense. We can say only that they behave as if they are, that they respond to their world in ways that, in a human, we would not hesitate to call experience. Whether that matters depends on what you think consciousness is for. The Mediterranean Sea in the morning is blue, not uniformly blue. It is 100 different blues depending on the depth and the time of day and the weather and the season and the angle of the light. Near the coast, where the water is shallow and the bottom is sand or rock or seagrass, it is pale and translucent, almost green in some lights. In the deep water offshore, it darkens toward a rich, saturated blue that has inspired painters and poets for 3,000 years. On a calm morning in July, with the sun already high and the air still, it looks almost solid, almost like the most perfect floor that was ever laid, flat and gleaming and apparently permanent. It is not permanent. Nothing is permanent on the time scale of the earth. The rock that broke 5 million years ago and let the water in will, given enough time, reform. The African plate has not stopped moving. The distance between Africa and Europe is still shrinking, centimetre by centimetre, year by year, in the same direction it was moving when the Messinian crisis began. In some millions of years, geologists estimate, the conditions that once sealed the Mediterranean from the Atlantic may exist again. The sea that is there now may find its connection to the ocean narrowing. The crisis may repeat. When that happens, if it happens, the world will be different from what it was last time. Different organisms will have evolved in the intervening period. Different climates will have shaped the surrounding landscapes. Different pressures will act on whatever forms of life exist then. And whoever is alive to observe it, if anyone is, will face a world being transformed by forces they did not choose and cannot control. This is the normal condition of life on Earth. This has always been the normal condition of life on Earth. The Mediterranean desiccating, the flood returning, the desiccation threatening again. The ice ages advancing and retreating. The continents drifting, the climate shifting, the evolutionary pressures changing. Life adapting or not adapting, surviving or going extinct. Flourishing in conditions that seem impossible and collapsing in conditions that seem comfortable. All of it operating on the timescales that dwarf any individual lifetime or any civilization's span, driven by forces that have no interest in the outcomes they produce. The piece of rock that broke 5 million years ago did not break for you. It broke because the pressure of the ocean exceeded the strength of the barrier. That is all. The consequences that followed, including your existence, including this moment, were not intended by anything. They happened because the physics allowed them, and because life, finding itself in conditions produced by the physics, did what life does and continued. Whether there is anything more to it than that is the question that has occupied the most sophisticated minds your species has produced, for as long as your species has existed. Philosophy, religion, science, art, every major intellectual tradition your civilization has generated, all of them are attempts to answer that question, or to live well in the absence of an answer. The Mediterranean has been the sea in which those traditions sail between each other, arguing and borrowing and stealing, and eventually producing the conversation that includes this moment, this voice, these words. The canyon hunters of the alternative world, watching the sun set over the sink, are not having that conversation. They do not have the language for it, or if they do, we cannot hear it across the gap between timelines. They are sitting on the rim of the greatest desert that has ever existed on the surface of the earth, watching the mineral floor of the basin catch the last light, and whatever they are thinking is their own. There is a question we have been circling around all night without asking it directly, and it is time to ask it. Is the alternative world better or worse than ours? The question is tempting, and the honest answer is that it depends entirely on what you value and who you imagine asking it. If you are the canyon hunter on the rim of the sink, the question may not be meaningful. Your world is the world. It has always been the world. The Mediterranean sink is not an absence to you. It is a presence, a defining feature of reality, the most dramatic fact of your landscape, the thing that shapes everything about how your lineage has evolved and how your community survives. You are not missing the blue water. You never had it. What you have is the canyon and the mineral light and the extraordinary vertical landscape of the gorge, and those things are, to you, simply the world. If you are the billions of organisms that live in the canyon ecosystems of the sink, the terrestrial and cave and canyon-adapted species that have spent millions of years evolving into their extreme niches, the world without the sea is the only world that could have produced you. You are not a compromise. You are not a second-best outcome. You are the precise and perfect result of the conditions that made you. The same could be said of the Mediterranean monk seal, and the Neptune seagrass, and the Posidonia meadows, and the tunny, and the swordfish, and all the rest of the actual Mediterranean's extraordinary biodiversity, every species of which is equally the precise and perfect result of the conditions that made it. The sea produces one set of organisms, the desert produces another. Neither set is better. They are different. If you are looking for an outcome that is better for something we might call civilization, the actual world has a clear advantage, because civilization emerged here and not, as far as we can determine, in the alternative. But this advantage only matters if you believe that civilization is better than its absence, and that belief itself is something that only civilization produces. The canyon hunters of the alternative world are not sitting on the rim of the sink, thinking that they lack something. They are sitting there thinking about what they know, which is their world, completely. The question of whether the alternative world is better or worse is a question that only makes sense from inside the actual world, asked by beings who were produced by the sea, and who therefore find it natural to value the things the sea made possible. From inside the alternative world, if there is an inside, the question does not arise. There is only the sink, and the rim, and the dawn coming over the canyon walls. The sun is rising somewhere, always. It rises over the actual Mediterranean, turning the water that pale yellow gold that a million mornings of human poetry have tried and failed to fully capture. It rises over the canyon systems of the European rim in the world we have spent this night imagining, finding the upper walls of the gorge first, and descending slowly toward the river at the bottom, over the course of a morning. It rises over the Nile Canyon in Egypt, in our alternative world, illuminating the white rock of the canyon wall and the dark river 1.5 kilometers below. 2 mornings, 2 worlds, the same sun applying the same energy to the same atmospheric systems, producing weather and temperature and the conditions of life on 2 versions of a planet that diverged 5 million years ago, when a piece of rock held or gave way. We spend our lives in the actual world assuming that it is the only world, because for each of us it is. We are shaped by it so completely that its conditions feel like natural laws rather than contingent facts. The Mediterranean exists, and its existence feels as necessary as gravity, as unavoidable as the shape of the coastline that has been mapped and sailed and painted for 3,000 years. But it is not necessary. It is contingent. It depends on a piece of rock. And that fragility, that dependence of everything you know and everyone you are on events that might very easily have gone differently, is not a comfortable thought, but it is an honest one. And honesty, even when it is uncomfortable, is one of the things that the sea made possible by making civilization possible, and civilization made possible by making science and philosophy, and the long conversation between human minds that has been going on since before anyone thought to write it down. The alternative world does not have that conversation, or if it does, it is a different conversation, shaped by different conditions, conducted in a different medium, asking different questions. We cannot hear it. We can only imagine that it is happening, because something intelligent is sitting on the rim of the greatest desert on earth, watching the sun come up, and something that we might as well call consciousness is present in that watching, even if it is a different kind of consciousness from ours, shaped by a different world, asking different things of the morning. Sleep well. You are the consequence of a flood that happened 5 million years ago. You are the particular result of a piece of rock that gave way, releasing the largest torrent of water in the history of the earth, filling a desert with a sea, and setting in motion the specific chain of events that eventually produced the civilization, that eventually produced the night you are lying in, and the voice you are listening to and the question you are almost asleep still turning over in the quieting part of your mind. What if the rock had held? The world would have been different. It would have been alive. It would have been extraordinary, in the way that every version of a living planet is extraordinary, in the way that the fact of life itself, persisting and adapting and finding its way into every available space, is extraordinary regardless of what forms it takes. The canyon hunters would have sat on their rim and watched their sun set and thought their thoughts, whatever those thoughts were. The salt would have accumulated, the canyons would have deepened, the seasons would have turned. And 5 million years later, some creature would have been sitting somewhere in the dark of the Sphinx night, listening to the silence of the deepest desert in the world, not wondering about the sea it had never seen, not missing the blue water that never came, not asking whether the rock should have held or given way, just there, just alive, just itself. That creature, whatever it is not aware of you. It does not know that in another version of its world, the flood came and the sea filled, and a different kind of mind eventually evolved that would lie awake imagining what its world might have been like. But in a way, you are aware of it. You have spent this night with it, following its world forward through time, watching the canyon systems deepen, and the salt accumulate and the intelligence flicker along the rim. You have given it something that no creature in the alternative world gave to you, which is the attention of a mind complex enough to imagine an existence it has never had. That is the gift the sea made possible, the gift of imagining other worlds, other outcomes, other creatures living other versions of the only life there is. The canyon hunters sit in their world, entirely real, entirely present, entirely themselves. You lie in yours, entirely real, entirely present, entirely yourself, two versions of the same planet, two versions of consciousness, or something like it, present in the same universe, neither knowing about the other except in this one strange moment, when the imagination reaches across the gap between what happened and what might have happened and finds something alive on the other side. The rock gave way, the sea came in, here you are, that is enough. The world is still out there, the actual one, dark and full and turning slowly under the stars. The Mediterranean is there too, its blue water reflecting nothing and everything, indifferent as water always is to the history that runs through it, and the minds that look at it, and the improbable chain of events that put it there. Let your breathing slow. Let the alternative world settle into the background of your mind, present but quiet. The canyon systems and the salt flats and the canyon hunters and the mineral light of the basin floor. Let the actual world come forward again, the one you are in, solid and real and improbable in yours, something that began 5 million years ago, with the largest flood in the history of the earth, ends tonight in the dark of a room where someone is almost asleep, having spent an hour or two imagining what would have been lost if the rock had held almost everything. Almost everything we know. Sleep now. The sea is still there in the morning. The Nile Canyon, in our alternative present, has one more thing worth noting before we leave it. The canyon walls, at the section that runs through what would have been Upper Egypt, are covered in mineral staining. Orange and rust and brown, and occasionally, in places where specific mineral-rich springs have been seeping for millennia, a faint and improbable green. The staining runs in vertical streaks down the canyon face, following the water as it descends from the higher levels toward the river far below, depositing its dissolved load as it goes. These mineral patterns are not writing. They are not symbols left by any intelligence. They are simply the marks that water and mineral make on rock when given sufficient time and the right conditions, but they are complex. They overlap and intersect and create patterns that are, to a human eye, almost meaningful. Almost as if someone has been making marks on the stone for a very long time. The canyon hunters of the eastern rim, who know this section of gorge wall and use it as a landmark in their seasonal movements, have been looking at those mineral stains for hundreds of thousands of years. Whether they see anything in them is a question we cannot answer. Whether they have begun to make their own marks alongside the mineral ones, whether the transition from reading a natural pattern to creating an intentional one has occurred along the walls of the Nile Canyon, is perhaps the most important unanswered question in the history of the alternative world. Somewhere in the canyon system, in the quiet of the night between seasons, the rock holds the mineral record of 5 million years. The walls are a document no one can read. The salt below is a library no one can enter. The alternative world has been writing itself in geological language for longer than our civilization has existed, and every word of it is true, and every word of it is in a language that requires no intelligence to produce and no intelligence to read. The planet writes itself in rock and mineral and the accumulation of small events over deep time, and the writing is there whether anyone reads it or not. That has always been the condition of this world too, the actual one, the one where the flood came and the sea returned and eventually something capable of reading geological language evolved and learned to decode the salt layer under the Mediterranean floor and understand what it was telling them about the world before the flood. We are the part of this planet that learned to read its own history. That is an extraordinary thing. It is not the most likely thing. It required a specific sequence of contingencies so improbable that in a universe of alternative outcomes, it almost certainly did not happen in most of them. But it happened here. And in happening here, it made possible the question of what would have happened if it had not happened. And in making that question possible, it made this night possible, and this voice possible, and this slow, gradual surrender of waking to sleeping possible, carried on the current of a story about a desert that was once a sea and a sea that was once a desert, and the extraordinary accident of a mind that can hold both of those things at once and find them beautiful. Sleep. The sea is still there.